most particularly, of course, the other insight, which is on Earth energy imbalance. And we've had this great recent publication by Ramsdorff and I think an economist. They nailed it down definitely. Climate change is accelerating. It's actually doubled in the past 10 years. I mean, that is, when you hear that, it's unbelievable, but this is what's happening.
Hello, and welcome to another edition of the Climate Emergency Forum. I'm Herb Simmons. I'm the author of A Climate Vocabulary of the Future, and I will be your host today. Well, every year as the climate crisis gets worse and more intense, at the same time, our understanding of climate science grows stronger. At least in theory, it grows stronger. Thousands of papers are published. Thousands of articles are written and discussions like we're having are occurring. And periodically, it's useful to sort of look back. What are some of the key issues? What are some of the key topics? One of the key insights? And that's what we're going to focus on today with our regular participants, Peter Carter and Paul Beckwith. Peter, as you know, is a British Columbia resident, retired medical doctor, and the founder of the Climate Emergency Institute. And Paul Beckwith is a climate system scientist, YouTube program entrepreneur from Ottawa, Canada. So the insights that we're going to cover come from a wonderful publication that is free, and if you can subscribe every day, called Carbon Brief. A little while ago, their 10 new insights. This was referring to more sort of last year. We're going to try to cover as many of these as possible. We'll include the following. What about the record warmth that we experienced mostly in 23 and 24, and the record ocean surface warming and marine heat waves? A third is, what about this global land carbon sink that's under strain? Biodiversity loss and climate change, they're working to amplify each other. It's driving an increase in dengue fever. We've talked before, just in our recent program, about infectious diseases and the climate crisis. It diminishes productivity. People can't work when it's hot. Simple as that. Then there's the issue of how do we scale up carbon removal to actually bring down the CO2 in the atmosphere? Do carbon credits markets work or not? They have serious challenges. And finally, should we focus on one or two key items or try to have a portfolio of actions to address the climate crisis? That's an ambitious agenda for 30 minutes, but we're going to do our best to focus on at least a few of these key issues. Please like this program, subscribe to our channel, go to our website, theclimateemergencyforum.org, take a look at and listen to our podcast that we now have for you. Leave us your comments and your questions, your suggestions for future programs. And as always, stay tuned till the end when I'll be presenting the Climate 3 of the biggest climate stories of the past week in under 3 minutes. So with that, as always, happy to see you, Peter. Why don't you lead off, take a couple of those big questions that I know you've been thinking about for quite a while.
Okay, thanks. You posed them all very quickly. That's good. As an annual publication every year by climate scientists, this is actually the biggest one, the most important one, the most useful one. They started it in 2017, right? So they've been doing this for nearly 10 years, and our global emissions, of course, are still going up as fast as ever. What they say is that they invite leading scientists of the world to review the pressing findings in climate change, and they summarize this and synthesize it. It's a really, really great report, very useful for us. I want to quote the press release because it's very strong indeed. The planet's natural carbon sinks are reaching critical limits, absorbing fewer emissions than expected as decades of climate change has weakened their capacity. Now, they go into this in detail, of course, and it's the land carbon sink and the ocean carbon sink, which, of course, absorbs about 50% of our emissions. Nature-based carbon removal projects are also at risk for a similar problem. Climate change is further undermining their long-term reliability and storage capacity. These are huge, right? These are absolutely huge. It changes everything. Scientists have recognized this would happen for decades, by the way. And
Right.
so the other thing that Herb mentioned is that large scale deployment of CO2 removal is necessary. Now, this is another thing we've known for decades. I can go right back to the fourth assessment in 2007, and you can see CO2 removal. Of course, the problem is with every assessment, the assumed successful CO2 removal gets larger. So there's a big problem with that. Climate and biodiversity, I was really glad to see that one. We're not told that very often. It's crucial that there's this feedback loop interactive between climate change and biodiversity loss due to ecosystem loss. So each of them makes each other worse. I was published on this some years ago. It's crucially important as well. That's really all I've got to say right now.
Thanks, Peter. Your point about climate and biodiversity, and in my book, I use the term, it's not original to me, bioclimate or the bioclimactic crisis. I think the more that we put those two, bio and climate, in the same word, in the same sentence, in the same thought, it's a symptom of our bifurcated, siloed worlds that they're looked at separately. And in fact, as I understand it, it's only been in the last few years that they've had joint major conferences with the biodiversity crowd and the climate crowd together. They used to meet almost always individually. I just want to emphasize that strongly. Your very important point about that, Peter, and to our viewers as well. You can't solve climate without solving the ecosystem collapse problem, and you can't address ecosystem collapse without climate. It's as simple as that to say. It's hard to do, but it's the kind of thing we need to put together. And with that, let me turn it over to you, Paul.
Thanks, Herb, and thanks, Peter. I'll talk about some of the other issues that Peter hasn't talked about yet, and also enlarge on some of the details of the ones he has talked about. But basically, many of these things are related. That's why I'm always emphasizing the climate system. A causes B causes C. So a lot of people are getting excited about the World Cup, which starts tomorrow. Heat waves could have a large impact on the World Cup. There's games in Mexico, there's games in the southern USA, and if we have heat waves that approach wet bulb temperatures, we're going to have players keeling over on the fields left, right, and center. So hopefully that doesn't happen, but I fully expect that to happen in some of these matches because it's extremely warm and they're open stadiums. And affecting labor productivity, of course, is a huge deal. Especially in the tropics. So it's estimated that 1 degree Celsius rise in temperature could affect 800 million more people in tropical regions with unsafe heat. That could reduce working hours by up to 50%. People may have to go to working in evenings instead of during the day, or certainly not during the hottest parts of the day. This is across primarily the tropical regions, but also extends into higher latitude regions. I think it's decreasing fertility rates around the planet. We're getting a lot more premature births, for example, and then when you have a premature birth, because of a heat wave, you get more problems. The outcomes for the child who has a premature birth are worse. Their health generally suffers from that. Of course, the massive heat is causing an increase in the range of mosquitoes that carry dengue fever. So not only do they increase the range of mosquitoes that can carry these viruses and bacteria and diseases, but they also lower the resilience of human body to be able to tolerate and recover from fevers that people get. The acceleration in heat is also causing more evaporation and evapotranspiration, and the more variability in rainfall patterns, of course, is affecting our ability to grow crops. So crops that are grown in regions where there's uncertain water sources have to rely more and more on extracting groundwater. So many reservoirs, groundwater reservoirs, are dropping up to 50 centimeters or more per year. There's some massive reservoirs in various continents, and as they get depleted, it's harder to extract the water. And if they're near coastlines, you can get seawater infiltration, causing all kinds of problems. Also, this is contributing to the global land sink for carbon being under strain and reduced. So we can talk about boreal forests. The whole process of photosynthesis is reduced when temperatures get higher and higher, especially if they exceed thresholds. Of course, we're getting more and more melting, thawing permafrost in northern regions, including regions where you might not think of it, like the so-called third pole in Asia, the Tibetan highlands, the whole area. We have an alpine environment, many crops grown, and many people living above 5 kilometers altitude. And of course, alpine regions are warming about 2.5 times the global warming rate. We often talk about polar regions warming much faster, but also alpine regions are warming much faster than the averages. The carbon credit markets have been mostly ineffective. They do suffer from integrity problems. People get kind of cynical. What's the carbon price really doing? And also the policy. People, they talk about slashing emissions, reducing emissions, but even if we reduced emissions to net zero, we still have all this CO2 and other greenhouse gases that have accumulated in the atmosphere that are causing the warming and extreme weather events. So we really need to look at scaling removal methods to get us back down to 350 or 300 parts per million so that we can survive in the long term. So lots of things covered, and most of them are connected extensively.
Well, you've provided a remarkable array of connections between probably a dozen different dimensions of the climate crisis, Paul. Thank you for that. And turn it back to Peter.
Thanks for that, Paul. I want to pick up on something which was very important and accurate that you said, which was for our long-term survivability. That's for us and most life on Earth. It's absolutely essential that we're able to remove CO2 from the atmosphere. I mean, as Paul has explained, that's abundantly obvious now with the accelerating atmospheric CO2 concentration and accelerating global warming. Now, I mentioned that the IPCC has had that almost from the first assessment. I referred to 2007. The problem is with their idea is that they've always delayed CO2 removal. It has always been after 2050. That's absurd. It's always been absurd. We need to be able to remove CO2 to have the capacity to remove CO2 as soon as possible, because really, again, that's obvious for the reasons I've just referred to. Most particularly, of course, the other insight, which is on Earth energy imbalance. And we've had this great recent publication by Ramsdorff and I think an economist. They nailed it down definitely. Climate change is accelerating. It's actually doubled in the past 10 years. I mean, that is, when you hear that, it's unbelievable, but this is what's happening. Also, I want to just say a little bit more on the accelerating sea surface warming that is quote unquote and intensifying marine heat waves, which is a very accurately expressed point in this paper, in this report. And they say it's unprecedented. It totally is. Ocean surface warming is skyrocketing. It's completely unprecedented. And they also mention something that perhaps most people don't realize is that it's compounding the risks from extreme weather events on land. And that's also, again, weakening the quote, weakening the ocean's role as a carbon sink. Another thing they mention on the northern hemisphere carbon sink, which Paul's already referred to in the boreal, is that we've got increasing wildfires, and they mention we've got permafrost thawing. So that's really, really important. So this is an excellent report, very important, most crucial. I'll just finish off by talking about this delay in CO2 removal. Now, the IPCC and all the scientists, they assume that we can successfully remove CO2. We can't assume that. We have no capacity now, and there's no future prospects for that to be able to do it. And I think Paul referred to that too. The economics has to be made friendly to removing CO2 from the atmosphere. The method, which is sort of most often mentioned now, there's a lot of opposition to this. There's an organization of scientists that oppose it, and it's called BECCS, Bioengineering Carbon Capture and Storage, and it requires vast amounts of land. And this report mentions that, mentions the problem with biodiversity and land security, which amounts to a human rights issue.
Thanks, Peter. I wanted to follow up on exactly what you just said about the assumption that we can remove sufficient carbon dioxide from the atmosphere. It seems to me, and following not super closely, but following a bit the state of the industry, I hate to even call it an industry, but the function over the last couple of years, the number of companies which had been in the hundreds, I think is beginning to decline. Many of those companies are closing down. And you mentioned economics, but the challenge is that it's a public good. If we're going to save the climate, economics should have nothing to do with it. When an invasion occurred in World War II, and the United States and Canada and other countries spent for a few years 40, 50% of their GDP, they did it to survive. They didn't say, well, it's not worth our independence and our freedom to spend more than 20% of our GDP. You spent what you needed to do to get the job done. And to me, the only way that carbon removal is likely to scale up sufficiently is that if a coalition of governments finally gets it, and of course that will require the public to demand it and say it's a public good. Unless we do it, we won't survive. So just go do it, and then let's let the next generation worry about paying off the debts or whatever else. Anyway, that's my perspective. Any thoughts, Peter, before I turn back to Paul on
Yeah,
that?
I just got a quick one because actually, I think last week, the annual state of CO2 removal, CDR, was published. And it's a very thorough report. It goes into all the methods and it has got nowhere. And according to the report, like it looks like it's not getting anywhere. Now, one thing that I didn't know was that the by far the most successful method that's being used is, and could be used a heck of a lot more, is biochar. And I remember Professor James Lovelock years ago saying biochar is very much part of the solution. Every farm should have its own biochar project. So I was quite surprised by that. I didn't know about it.
Before I turn to Paul, let me just say that I'm a big fan of biochar. I'm probably more of a fan than I understand it at all, exactly how it works. But one of the folks that I've gotten to know, I'll give him a plug on our show now, is Albert Bates, who has written a brilliant book about biochar. And I hope we can get him on as a guest one day. He's also written a book about what life is like at a COP, kind of like our friend Nick. So, anyway. But I think biochar is definitely a sleeper and has some real potential to have multiple co-benefits as well as pulling CO2 down from the atmosphere. Paul, your turn.
If you look in the paleo records, paleoclimate, we've gone through repeated cycles of ice ages and warm periods. And in those cycles, we've gone from CO2 levels being about 200 parts per million up to 300 parts per million, 300 being in the warm periods, 200 in the ice ages. So we know there's natural mechanisms that can change the greenhouse gas levels in the atmosphere. We know when large volcanoes go off, spreading ash, blocking some sunlight, cooling the planet, and causing a proliferation. The ash contains iron, and we get a proliferation of life growing in the ocean, which then draws down CO2. Attending the biodiversity conference a few years back in Montreal, the UN conference, I mean, they had a goal of protecting 30% of the surface area of the planet by 2030. If you just think of where the carbon sinks, okay, so 50% of our emissions go to land and ocean, into land and ocean sinks. I know the ocean's about 26%. So it's about 50-50, the balance. The oceans are vast. Just think of how much carbon is embodied in the flora and fauna on this planet. So we used to have massive forests with massive, century-old, even thousand-year-old trees containing huge amounts of carbon embodied within them. If we replace those by grassland. It's no wonder that there's a lot less CO2 in life, basically. So, we've depleted about 90% of the large marine life in the ocean. So if we just aim to try to restore biodiversity to what it was, say, 100 years ago, that would involve capturing or embodying huge amounts of carbon in life, both in the oceans and on the land surfaces. So there's lots of things that we can do. We just have to understand. I mean, we understand enough about the processes to do these things right now. But logic and governments seem to be mutually exclusive at the moment. We're seeing a turn away from science and engineering in the US. We're seeing scapegoating of climate scientists. We're seeing lots of misinformation out there. We have a lot of different reasons why we're not doing things that we can, but that doesn't mean we won't suddenly, start working harder towards some of these other things. I mean, I'll just mention concrete, okay? It's one of the most popular, most common human-made substances on the planet. The Romans could make concrete that would last 5,000 years. Our concrete in a city or whatever lasts 30 to 50 years. And then when we have to rebuild stuff, it uses huge amounts of carbon, releases huge amounts of carbon. So there's a lot of things that we can do to improve things, but we just don't seem to have governments capable of recognizing and pushing through methods because of the way power structures are. I mean, lobbyists from powerful companies are controlling government actions, and we're not even going for the largest. We're trying to decarbonize, we say, but we need to decarbonize, put the money into the easiest things to decarbonize first, but there's too many vested interests lobbying that prevent us from doing that. There's a lot of things we can do that we're not doing right now.
That's for sure. And a lot of things we are doing, but we aren't doing well enough or at the scale that's needed or with enough evaluation to determine whether they're even working. And the other thing is, as we've talked before, some of what we're doing now is beginning to become overwhelmed by the feedbacks. So, how do you deal with planting more forests and whatever when they burn down a day later, or the soil chemistry changes and the microbes change in such a manner that emissions go up into the atmosphere rather than are brought down, sources and sinks. I mean, these are the sort of the race that we're having. It's kind of what I call the great race, the great climate race between nature moving us in one direction and us trying to do a counterbalance. And I don't know anybody on this planet who would look objectively and say we're winning. But I want to ask both of you. I don't think we've touched upon, or if we did very shortly, or not as much as I think we ought to, on number 5 on this list, which is the acceleration of groundwater depletion from climate change. I just want to say this is sort of related to that is something that I looked at a fair amount in writing my book, and that was the whole issue of saltwater intrusion from sea level rise and so forth, that is having a devastating impact on the ability to grow crops in many countries with tens of millions of people, and farmers have to move out of those delta areas as saltwater begins to take over. We have what's called ghost forests, certainly in the United States along the coastal area, where the trees are barely alive, or in fact they're dead because the salt level has gotten too high underneath. It's a spreading, and it's not often given as much attention as it should be. So, Peter and Paul, talk a bit about groundwater.
I can give you the quote from the report, which, as you say, is really, really important, Herb, and not many of us are actually aware how important it is. So it's number 5, as you say, and it is, quote, climate change is accelerating groundwater depletion. So this is yet another crucial aspect of our biosphere and planet, which is accelerating in a bad direction. And they mention that this is a threat to agriculture and food security, unquote. And as Herb mentioned, they also mentioned the saltwater intrusion. And of course, yeah, he's absolutely right. That's also a regional threat to agriculture. So, yeah, groundwater depletion, yeah, you're right, it's huge.
Oh, what's the mechanism? It's one thing to say climate change is accelerating groundwater depletion. What's the connection? Tell our viewers how we should look at the two.
Groundwater, that term describes what it is. It's water reservoirs under the ground. A very large one in the US West is the Ogala Aquifer or something. So you have to look at how the water is like we're taking more and more water out of the ground, especially in regions where the soils are good to support crops, and we have a long history of growing crops, wheats and things in these regions. But the rainfall patterns have shifted, so they need to rely more on irrigating their fields, and they pump the water up from wells and things, and that depletes the level of water in the ground in these wells. How does the groundwater recharge occur? Well, normally, if you had rain throughout the year, it falls on the ground and it takes time to trickle down through the soils and replenish the groundwater. What we're getting with more and more climate extremes is we're getting, long periods of time, durations of time where there's no rainfall whatsoever. That's not helpful for the groundwater. We're also getting periods of time where we get torrential rains, and that's not so greatest for the groundwater either because we get so much water in a short period of time that it just runs over land and it causes lots of erosion, pulling away soils, but it doesn't have time to infiltrate into the ground to replenish the groundwater. And also, when you get water depletion, I mean, you don't just have a big vacuum, a big open space in the ground, you get subsidence of the land. Typically, rivers, they run fast when there's a sharp grade in the land, but as you approach a coastline, you get these coastal plains. So then the river water slows down and you get deltas forming, you get many tributaries and deltas. And that's why traditionally you also get sediments carried in the rivers. That's why we have some of the most fertile farmland is right along coastal regions in these deltas. And of course, with sea level rise and with depletion of groundwater, instead of being replaced by land subsidence, you can get water infiltration from the ocean into those regions, making it salty water underneath the ground instead of fresh water. And obviously, you can't use that. You have to filter out the salt if you want to use it for irrigating crops and things. So I play a lot of chess. I'm going to play in the Canadian Open in a month. One of the things in chess, if you play a chess or another strategy game, if you look at only one part of the board, then you're not going to play very well, right? You're going to miss like long range pieces that affect that one part of the board. You have to look at the overall chessboard, get a big view picture to understand how the pieces connect and so on, strategies and tactics. Well, it's the same. We've talked about 10 issues, but if we look at them in isolation, it just doesn't work. You need to see how they were all related and interconnected because that's the way reality is in our world. And too often people try to over specialize.
Great analogy. And there's another thing, and that is there is an understanding now, a very solid understanding among scientists, that they are not allowed to stray outside of their range of expertise, right?
Mhm.
So that really makes this reductionism of science even worse.
Well put. Well, I think we have covered pretty much each of the 10 of these. My hats are off to Peter and Paul. You've been able to weave in not only the individual issues, but also how they're connected with each other. And that's more important than anything else. As you said, Paul, it's the system that counts. It's not the individual issue. And can almost never solve a problem by just focusing on the one issue. What we try to do here, you, the viewers, will tell us how successful we are, is to bring together a whole variety of different issues to your attention and to try to see how they connect with each other each and every week. And for this week's Climate 3, the first picks up on something we spoke about just a few minutes ago. In this case, the country of Canada, that my co-panelists are very familiar with and our producers because that's where you live. Well, there was just a new study that came out that had to do with the forests and are they sources or are they sinks of carbon? Sink means it sinks down into the ground. It holds it, it stores it, it keeps it out of the atmosphere, the carbon. A source means it comes up out of the ground. And throughout millennia in history, every kind of natural system has some degree of sources and sinks because carbon is cyclical and it's very complicated. And it's easy to make simple observations that, oh, this is turning into that or that, but it's usually more complicated. But a study showed that, first of all, there is real lack of data, surprisingly, when I read the study about what is actually happening in Canada. But just getting to the conclusion is, and the authors say, we show that Canada's terrestrial ecosystems have been a carbon sink since the mid 20th century due to wildfire and timber harvests before 1940. In other words, based upon what happened before, it's been a sink. But since the early 2000s, and this is not surprising, wildfire disturbances have been driving Canadian forests towards becoming a carbon source, which is not good. It's as simple as that. And continued increases in wildfire activity will further weaken and may ultimately reverse Canada's major role as a carbon sink in the whole world ecosystem. One more study confirming, I think, what we've talked about here several times over the years. Second, the United Nations issued a major report on the world's oceans. And of course, it's hard to look at the oceans and if you know anything about them or if you've read anything about them without feeling very sad. And this report doesn't provide much good news. It does provide a bit, but it says the oceans are under, quote, severe and accelerating pressure from human activities. And this is the key one. The rate of sea level rise is double that of just a decade ago. This is not rate double 100 years ago or double World War II or whatever. I mean, so we're getting that word that you've picked up before, Peter, accelerating. The acceleration in sea level rise has begun. Whether it will continue in what way, we certainly can't be complacent about. The stressors include pollution, fishing, climate change, biodiversity loss. I think most of you know what's happening. Basically, it was 2 millimeters a year of sea level rise prior to 2015, and now it's 4.3 millimeters a year in 2023. Now, that varies greatly around the world, but that's an average. Not good news, but at least we know about it, and hopefully we'll get the political will to do something about it. And lastly, I just want to take a minute or so, because I'm sure most of you may not be able to, for one, or choose not to subscribe to the New York Times. But they had an article very recently titled Laboring Under Delhi's Harsh Heat. Workers Must Choose Health or Wages. I just wanted to read a few paragraphs because it really moved me and seeing the photos as well. They talk about an auto rickshaw driver in Delhi. He normally works 12-hour days to make his ends meet. He needs to raise that money for heart surgery. But as temperatures have already climbed above 100 in April and May, he basically, if he works fewer hours, which he needs to do for his health, he can't make enough money for his family or for his heart surgery. And that's the dilemma for literally millions of workers, not just, of course, in Delhi, but everywhere. As the Times put it, the summer forces them into a bitter trade-off between health and income. On the hottest days, the surface temperature of the ground in Delhi can reach 140 degrees Fahrenheit, which I understand as an American, I'm not conversant with centigrade, but I understand it's 60 degrees Celsius on the ground. And that, of course, will burn your feet and do lots of other things that you'd rather not have done to your body. So it's a very moving article. Just a reminder, if you're sitting in your air-conditioned house, your air-conditioned office, or your car as you're driving somewhere, or even on the subway, you're probably cool right now if you're in a Western country, on many countries. But there are billions of people who don't have that luxury. So with that, that is the Climate 3. Thank you again. As always, we appreciate any likes, any subscriptions, any donations. Listen to our podcasts. And as always, thank you, Peter. Thank you, Paul. And we look forward to seeing you next week. Goodbye.